Frequency response of RC high pass filter. In the previous lecture, we have seen the frequency response of RC low pass filter. Again, you can see that this is an ordinary circuit consisting of a C and R. And in the low pass, what happens? C comes here and R goes there. So this is just an inverse circuit. And similarly, by using the voltage divider concept, we can get the response as R divided by R minus jXC, where XC is 1 divided by omega C, and the final transfer function is 1 divided by 1 minus j omega C by omega. And omega C is 1 upon cutoff frequency, 1 upon RC, which is cutoff frequency here. And when we write the magnitude as well as phase in single expressions, we can write 1 divided by omega C plus omega square, this one, and the angle phase will be minus of 10 inverse minus this, so it will become 10 inverse omega C by omega. No negative sign will be there. And the high pass filter, it will pass all these signals having high frequency above certain cutoff frequency, and it will attenuate all the signals below that certain cutoff frequency. So when we see the frequency and phase response here, just revert to the low pass filter. Look at here, when we are going towards high frequency, the signal, gain is increasing, means the signal is passing. And when we are going towards low frequency, the gain is reducing, means signal is suppressed, the signal is attenuated. The same concept with low pass filter. You see here at cutoff frequency, the gain from maximum is minus 3 dB, so 3 dB down, and therefore the cutoff frequency is also called as 3 dB cutoff frequency. There we were writing the slope as minus 20 dB. Here you see the slope is increasing here, so the slope will become plus 20 dB per decade. And this is called as high pass filter because high frequency signals are allowed and low frequency signals are attenuated. When you look at the phase response reverse to low pass, you see here at 0 it is 90 degree. When we go here omega, when we put 0 it becomes 90, that is infinite. 10 inverse infinite is 90 degree. And when we put exactly at omega equal to omega C, it becomes 10 inverse 1, which is 45 degree. And then when we further increase omega, it becomes like this. So this is a phase response of RC high pass circuit or high pass filter, and this is frequency response of high pass RC circuit. So it's very simple. In a very simple way we can understand the frequency as well as phase response of RC high pass filter, just getting the transfer function and trying to plot the magnitude and phase with respect to frequency. We will get frequency and phase response, and we can easily obtain the expression for gain and then cutoff frequency. The cutoff frequency is called here as a 3 dB cutoff frequency. Obviously here the 3 dB cutoff frequency is called as a lower cutoff frequency, because we have to know that from which low frequency signal is allowed. And in case of low pass filter, the cutoff frequency is generally called as higher cutoff frequency. Here it is lower 3 dB cutoff frequency. Thank you.